In exercise 2, you will create an OS design for board support package from the prior exercise. You will then customize that design by adding components from the catalog and build the result. This OS design will be used in other exercises and labs today, and will be a suitable platform for running a variety of Windows CE applications. You will learn how to create an OS design from the standard design template, navigate the views of the workspace, identify the catalog features, extend the standard design by adding some more catalog items to it, and finally set up the build configuration for your run image and build and run the image. So let's get started. On the development workstation, we have already launched the platform builder. On the file menu, I select new platform. That launches a new platform wizard. Click next on the welcome screen. Type in a name, for example, Apex Platform. Please pay attention that Apex Platform will be generated under PB Workspaces under WinCE root directory. Click next. Out of the standard board support packages, choose the iCop Vertex 8650. This is the board support package we just installed in previous exercise. Click next. Out of the design templates that Microsoft has already provided to you, for this particular exercise, we choose Internet Appliance. This particular Internet Appliance is basically a template that provides the starting point for a browser-based consumer Internet appliance with a fixed display, such as a CRT or LCD display and a keyboard. Click Next. In this section, review the particular options under Applications and Media. Make sure that you have included .NET Compact Framework. Just in case if you want to do additional programming, you could also choose a standard SDK for CE. As you see, Microsoft has automatically supported Internet Browser, Windows Media Audio MP3, and basically MPEG 4 video. You could also include media player, file viewers. As you see now, PDF viewer is now available part of Windows CE, and you could choose any other options as you wish. However, in order to smooth out the operation a little bit and shorten the time in order to compile this particular platform, I just go with the default. Select Next. Under Networking and Communications, as you see, we have the following options. Since in this exercise we never choose Wide Area Network, we just don't select that. Or you could just get the default and go on. However, we need to have Local Area Network or LAN. As you see, that would be Wired Local Area Network. Just in case if you want to have a support for wireless, you could also choose that. iCop eBox 2 requires you to have Wired Local Area Network. The rest of the options are optional. Click Next. And as you see, completing the new platform wizard gives you the specific screen. They give you an option to modify the build options for the debug and release configuration of your OS design without closing this wizard, or you could just simply finish it and go on. We just go ahead and choose Finish. It will take basically a few seconds for the platform builder to finish its job. As you see on the status bar, it says copying and adding catalog items to your platform. The progress bar shows how much time you need to wait for this task to be finished. On completion, Platform Builder will display the Workspace window. This is the Workspace window, and as you see, this is the name of my platform, Apex Catalog Items. Below that, you see device drivers that have been included from the template. I've chosen the Internet Appliances, and as you see, there is a networking option. I have serial support, I have basically storage devices, I have USB support, and under iCub itself, we have device specific drivers. So basically, the device drivers that you see in here, they are platform independent drivers that Microsoft supports, part of the catalog. However, under your board support package, you have device specific drivers that are necessary in order to work with your platform. Below that, you see the type of a platform you're dealing with, Internet Appliance. As you see below that, you have applications, end user, you have applications and services development, which is like .NET Compact Framework, as well as other information. Under communication services and networking, you have networking features. As you see, we already have network utilities. We have basically other options such as shell, internet client services, and so forth. I give the chance to you in order to go and explore a little bit and see what other options we have in here. You can spend as much time as you want in this section. So what we need to do, we need to make sure that the configuration, active configuration that we have chosen is the desired one. As you see, we have two separate configurations. We have release and we have debug. Usually, if you wanted to debug your platform, you need to choose the ICOP Vertex 865086 debug version. However, for this exercise, we don't need to go through the debug. We can just rely on a release. This setting is on the toolbar, as you see, and basically we could go and simply from OS design view get the available options in here. By choosing the debug section, you are just basically changing the entire platform to be based on the debug. So basically Microsoft adds a debug DLLs by the time you want to compile and build your image, and that adds some symbols. So as you realize, debug will be a little bit larger as far as the generation of the symbols, and it will run a little bit slower. So after you finish testing and debugging your platform, before final production, you need to change that to the release and build your image on the release, and then basically use that image part of your final production. So let's explore the rest of the tabs. As you see, we have OS design view, which I've already explored it. We have also parameters view. Let's take a look at this particular parameter section. As you see, we have some common files and we have some board support specific files. Now, as you see, these files specify the attributes of the runtime image, including the registry settings. As you see, that would be platform.reg. Let's go ahead and examine that. Double clicking on the platform.reg, as you see, it basically shows you how to set some registry settings like HK local machine, drivers, and so forth. The explanation of these specific files will be discussed throughout other sections of the course and other exercises. So just wanted to pinpoint the type of the files that we're dealing with. We also have the DB, which is basically available for internal database that Windows CE supports. This is a little bit different from SQL CE that Microsoft supports. You have the DAT file, which is a location in which we can go ahead and create directories and create files and subdirectories and shortcuts. We have the BIB files, which is indicating what kind of modules or programs need to be added, or particular files need to be added to your image. And finally, we have the config.bib, which allocates memory areas. As you see, for ICOP, we have these memory settings. Modification of these files will definitely impact your image, and perhaps if you don't pay attention to the entries that you enter in these files, you might experience some problems building the image. However, let's go ahead and explore more options here. On the file view, as you see under the Windows CE, on the platforms, now we have ICOP Vertex 8650. We can right click at it and select explore. That automatically explores that particular directory right here. And as you see here on the address bar says Windows CE platform ICOP Vertex 8650, which we have already went through it. However, there is a new file got added in here, as you see, and that would be basically the ICOP Vertex 86. And under this section we have basically a BIF file which comes from a different exercise. As soon as I build the image, you'll see that that particular platform will be added, and the Apex platform BIF file will be available in here as well. Let's go ahead and simply continue with this exercise. Now let's go ahead and add some new components into this image. From the core OS, I expand the application services, and I'm going to add a smart device authentication utility, which is required for basically downloading and debugging Windows.NET framework or compact framework application into your image. So we just right click at it and add it to our OS design, and that will refresh our OS design view. And as you see now, a smart device extension utility has been added. Also, let's go ahead and add a different component as well. Below application end user, I also need to include the cabinet file installer and uninstaller. That is also necessary in order to create applications, .NET Framework applications, either via Visual Studio .NET 2003 or perhaps using embedded Visual C++ 4.0. We need the cabinet file installer and uninstaller to be part of our image. So as you see, that also got added in here. The other options that you can include would be under communications, and you could go under networking features, and you could also include networking utilities such as IP config, ping, and so forth. We're also including that one. So as you realize, we have basically gone through modification of our platform, original platform based on Internet Appliance, and we add our own components into it. Now the next section requires us to go and make sure that what type of active configuration we are dealing with. You could either choose that via the toolbar, or you could go through the platform and basically under the build itself, build OS itself, we can go through set active configuration and choose it from here. Now part of this section, before we build our image, we like to also show you how to add a new project part of the same exact platform without using Visual Studio .NET 2003 or embedded Visual C++ 4.0. From the file menu, I like to select new project or file, and as you see, this will basically show me a specific wizard in which I can go ahead and create simple C++ kind of applications for my platform. So therefore, Platform Builder also includes limited sections of creation of some applications, such as a very simple Windows CE application as well as the Windows CE console application. These are good for device driver developments. However, in order to create an application, we do recommend to use embedded Visual C++ 4.0 or Visual Studio .NET 2003. So let's go ahead and choose Windows CE application. As you realize, the location would be basically placed under Apex platform. That is the platform that I'm added at the moment. Let's go ahead and give it a name, hello from, for example, Apex, and click OK. This section is a feature section. It is not required to put any information in here, but it would be nice in order to add adequate feature name in here, and that will basically distinguishes your project from the rest of the projects that will be added perhaps in the future part of your platform. So for example, I put in like Apex Infotech demo application. You could put the date, version number, and the size. If you know the size of your application, that would be also good for prediction of the total size of your image. Manufacturer, for example, we type in Apex Infotech Inc. and perhaps contact info, we type in www.oneapex.com. Click Next, and as you see, you could choose an empty project, a Windows Simple CE application, or choose a typical Hello World. You could click Finish in here or go to the next window. In the next window, as you see, we have different release type, which we don't want to discuss it at the moment. You have different options in here that will be discussed in future sections of this particular course. And here we can simply go ahead and click Finish. That will automatically add a brand new section to our platform, and we can see that project got added, part of the OS design view. That would be under projects, and as you see, hello from Apex is available now. In this scenario, from the basically build project, we are going to build all available projects in here, which only compiles your existing project. So if I click build project, it takes a few seconds in order to build your application. This is very similar to compiling your application in a Visual C++ environment. Let's go ahead and see what are the issues in here. We have like 2 separate errors, and as you see, the building application requires you to know exactly the platform specific section of your basically library. Since this project requires you to have a pre-existed images or libraries for the core operating system, the project itself could not be built. So I just wanted to prove to you that building the project for a particular platform requires the libraries for that platform to be available. So in order to do this, we need to go and first generate the sysgen for this particular platform. Now you need to basically pay attention to this section. This is a very important note. If you choose build and sysgen, that will also build some of the private files that Microsoft includes. Basically, this will recompile the source code for a number of standard Windows CE components if you choose build and sysgen. These components are distributed in a compiled form as part of the platform build and installation. Rebuilding these components is not required unless you have modified the Microsoft source code in the public or private trees, which you should never do anyway. It is recommended to use the customization option of the platform builder and remove this menu, only this menu section, and so you don't accidentally click on it. The only thing you need to click on is sysgen. But before you build the option, you got to go and make sure that our projects has been set correctly. So in order to do this, we can right click in here and select settings. That basically opens up a particular platform builder settings in here, and under this configuration you can click on build option. Make sure that the following options are enabled. Enable CE target support, as you see. Enable eBoot space in memory. Enable full kernel mode, and enable Kiddle. These 4 options are required. Make sure that they are selected, and then you can select OK. So we are basically ready to go ahead and build our OS image. As you see, these 2 options are already selected. It will make the image, and then simply we can go ahead and just wait few seconds and see that our platform build image has been completed successfully. You should get 0 error, and there might be some warnings, which sometimes you should just ignore those warnings. For example, if you get like 3 different warnings, these executables or other files probably they had some issues and they are giving you some warnings, and you could basically just go ahead and ignore them. Remember that some warnings are not a serious problem in the platform builder and software configuration, and perhaps sometimes you don't get any warnings. So this process, depending on the speed of your CPU and the hard disk space and so forth, it takes anywhere from basically 5 to 15 minutes. And for this section, we just need to wait and see if the demonstration is going through completely, and we can continue with the rest of the exercises. So we can take this time and stretch a little bit, and we can continue after the build image is successfully completed. You just have to wait for the image at the end of this section that says build demo, name of your platform, which is Apex platform, build complete with 0 errors. We just have to wait for that.